Welcome back to Matt's Automotive Channel. This is part 2 of the gauge flicker video. I finally received the parts necessary to optically isolate the dimmer side of the switch to the gauge side of the switch. So anyway, we'll be putting those parts together. I'll show you exactly what I did, and hopefully this will work and get rid of our problem. So let's get started. Alright, so what we have here is optocoupler, or optical isolator is what it's sometimes referred to, and that's this little device here. And so it's basically broken up into two different circuits. We have one circuit on this side and another circuit on this side. So this side here is going to represent my pulse width modulated side. And then this side over here is going to be the side that's going to be used to power the air fuel gauge to eliminate the flicker. And we're going to smooth the signal out using this capacitor here. I'm not going to go into detail into the size resistors and capacitors in this particular video. If you're interested, I'll probably create another video showing all that level of detail. But anyway, to give you an example of what's going on here, this green LED represents the pulse width modulated side, and this will be the gauge side. And when I push this button here, it's going to close this circuit and allow current to flow on this side, and then this optocoupler here will engage the other side, and this is the side that will power the gauge. And you'll see that the LED on this side is going to be smoothed out. So when I push here, you can see that on the PWM side it comes on instantly, and as long as this is pulsing, the other side never really loses power. It dims but won't lose power, and this is what's going to keep a more consistent power going to the gauge to eliminate that flicker. And again, just to re-emphasize, the flicker isn't necessarily caused by the fact that this is pulsing. It's due to the fact that this side completely loses power, and then what happens is the gauge thinks, oh, okay, no power, no dimming circuit, and then it goes to full brightness. So when this goes all the way to 0, the LEDs on the gauge go to full brightness, and that's what causes the flicker. So every time this has power, the gauge dims. Every time it doesn't, it goes bright. And the frequency of the PWM side is 100 Hertz. So with that kind of frequency, we're not going to see any variations here. This will pretty much stabilize and be a flat line, unlike when I'm pushing the button here. Before wrapping this up into a nice neat little package, we'll put it onto the car and hook up the PWM or the dimmer side to this, and then we'll measure the output from this and see what it looks like, and then hook it up to the gauge to make sure it takes care of our problem. And then if so, we'll go ahead and wrap this up into a nice package and put it into a box, and then wire it up under the dash. So again, the whole idea of using this optocoupler is to isolate the two sides. So no matter what happens to the gauge side here, it's not electrically connected to the other side, so I don't have to worry about damaging any components on the car side. All right, so now I have a temporary hookup here, and so we'll test this out. Let's turn the ignition on. The gauge should come on. And as we turn the switch to on, this should dim a bit, because that would be nice. Yep, goes down a little bit. And then as we move the knob here for the dimmer, you can see the LED on the board goes up and down. And then we can see here, there's the dim. And then that goes up and down. No flicker. All right, so it works. All we need to do is package this up and mount it underneath the dash and button it all up, and we should be good to go. All right, and then just to show you, this isn't really as complicated as it looks, but basically what I got going on here is I'm taking power here from the dimmer switch, and that's going to feed our 12 volts down here on this side of the circuit, and then the other side is the ground here, and that's what's energizing the green LED. And then on the other side, we're hooked to 12 volt power, and then the other part is the output from the octocoupler right here, and then that is going to our gauge wire right here. So we got this coming in PWM on this side, that gets transferred over here optically to this side, and then we got our own separate power source from here, and then that is loading up the capacitor here to smooth the signal out, and then getting output here to the gauge side. So not that bad. It just looks like a mess of wires here. So anyway, we'll package this up real neat and then put her back together. One other thing to note on the gauge side, I did go ahead and remove the resistors because I'm not powering the LED here anymore, which would have blown it out if I'd given it the full 12 volts. So I pulled those out because this gauge here requires the full 12 volts. So anyway, that's why that's missing. So it actually simplifies the circuit a little bit. All right, let me update you on where I am at this point. I went ahead and finally cleaned up the board that I was testing with and then put it in the car. And then I noted that when the dimmer went all the way down to the lowest setting, that the display on the airfield gauge would pop up to full brightness again. So apparently I had gone below some threshold that gauge perceives as being dimmable power. So then I figured, okay, well, I'll play around with some of the resistances on the board and actually go to a lower ohm resistor, and that way it would provide more power going to that gauge at the lowest settings. Well, I did that, and then I blew away the optocoupler. It was rated at 50 milliamps, and apparently I exceeded that. So then I thought, well, I have several other options. I could just get another optocoupler that's made for higher current. This gauge here is drawing around 200 milliamps, and the optocoupler I had was 50, so I needed something that was about 4 times more capacity. Another way to do it would be to use a MOSFET and then isolate the isolated circuit and then provide full voltage. Or I could put in some kind of voltage regulator, but it's like, boy, this is getting difficult. So anyway, I went ahead and I proceeded to find out exactly where the limit was as far as what I could deliver to the gauge using the current setup. And inadvertently, I had hooked it up, bypassing that optical isolator, and the thing worked. And then I realized, oh no. And that was my other option, was to just wire in a capacitor into the existing circuit and just smooth out the pulse width signal. I was a little hesitant to do that because I didn't know if it would impact any of the other dimmable displays, like even the infotainment system there is dimmable, and I didn't want to risk damaging that. However, it worked. So I figured, okay, I'm just going to get rid of the whole optical isolator board and then just use a single capacitor. And so that's what I did. After all of this, I ended up with just a single capacitor. This here is a 43 microfarad capacitor. And basically on these type capacitors, they have a plus and a minus side. So on the minus side, I just hooked up a negative that I'm going to just go to ground with. And then the other two going to the positive side, one is going to be the pulse width modulation signal coming from the dimmer switch. And then the other one is going to go up to the gauge. So anyway, this is how simple it really is. This is all you need to do. I don't advocate necessarily doing this for other cars. It worked out for this particular car. I'm not so sure it would work out for every car under every circumstance. So be careful of that. It's definitely safer to optically isolate the signals, which I was originally trying to do, but this works for this car. So this is what I'm going to use. All right, so as far as hooking this up, this is the capacitor here, 43 microfarad, and I'm just using the 3 terminals here. So right here is from the dimmer switch. So I got one going from there. This is going to be the pulse width signal right here. And then I got the negative, which is just going to go right here. And then gauge. So we'll just plug in the one for the gauge here. And that's all you need to do. This will eliminate the flicker. Now I'm left with a little connector here that I was using when I used the optical isolator because I had a separate circuit for the other side, which I'm not going to need, so I won't need this. So I'll probably just cut this off and then splice these wires together and then tuck it all up here. But I'll real quickly just test this. All right, so I got it wired in right now. So let's go ahead and turn the ignition on. And let's see. In fact, I'll just start the car. There we go. There's our display. Now I'll turn on the lights and this should dim down. Alright, so I think I'll go ahead and end the video here. We have a system that works just fine, and on the next video I think we'll go ahead and get this scene out on the road and test out those new tires that we got. So till then, I'll see you next time. Bye bye.